Okay, hey, welcome to the Science Hutch. We're going to be talking about how to use motion graphs of position versus time, velocity versus time, and acceleration versus time to find other things. So maybe you graph position and time, and then you want to find velocity. Well, how do you do that? Or maybe you graph velocity versus time, and you want to find acceleration. You could also find the change in position, which we call displacement, from that graph if you know what you're doing. And so I have a little memory trick here that I use called the motion graphs mountain, and I think about 3 levels to a mountain. At the base of the mountain, you have the most basic way of graphing motion, like position. We have X for horizontal, we have Y for vertical, and we have Z for into or out of the page. Now, if you graph this on the Y-axis and you graph time on the X-axis, then you'll have a position versus time graph, which maybe if it's horizontal, you would say X versus T. So here's horizontal position, maybe measured in meters, and here's time measured in seconds, and maybe here's position 0 and time 0. And then you move forward in the positive direction, then you get a best fit line for that, and then you find the slope of that line. So you take maybe this point here and this point here, and you look at the rise, and then you take this point, and you look at the run. And so you get your rise over your run, and that would be your slope. So you use an M for slope in math class, but in physics class, this slope is not going to equal an M. This slope is going to equal your velocity, because velocity is change in position over change in time. It is also the rise and the run when you graph position on the y-axis and time on the x. Now, back to the mountain. So you see this little man climbing up the mountain. He's so happy to be here with his little cane walking stick. He's taking the slope of the mountain, and so you go up the slope of the mountain and you find a new level of the mountain. You find velocity. So the slope of a position graph equals velocity. Isn't that just wonderful? Now that also works if you were to graph velocity. If you were to graph velocity versus time instead of position versus time, and then you take the slope of that, you would find acceleration. And so we see a little example on the left. If you take the slope of this line, you would get a change in your velocity from 0 down to, maybe let's say this is -3. And that would happen from 0 seconds to 5 seconds. And so that would be a rise of a run of, look over on the right here, -3 over 5 meters per second, and then that gets our seconds combined, so we get meters per second squared, and those are our acceleration units, so little a for acceleration. So once again, taking the slope of a velocity line gives us the acceleration. So keep on trucking up the slope of the mountain and you get to the highest level. And in the snow caps the acceleration, you're like, yay, here we are at acceleration. If you were to take the slope of an acceleration line, you do actually get something. We call the change in acceleration over time jerk. But as I like to say in Physics 1 and AP Physics 1, we don't deal with jerks. So we're not going to have changing accelerations. Now, if you graph acceleration, you might want to come back down and look at the areas underneath where you are. So now we want to get to the area underneath acceleration, which is the velocity area. And I'm using the word area on purpose because over on the right side of the mountain here, I'm illustrating what you get if you take the area under a graph. So if we have this acceleration here of 2 meters per second squared constantly happening as time marches forward for 5 seconds, and we take the area underneath that, it's going to make a rectangular shape that you see here in orange. And so the area of a rectangle is length times height, or length times width, whichever way you want to look at it. But in this case, the height is an acceleration value, and then the length running is a change in time. Now, acceleration times change in time actually gives us a change in velocity. So if we're accelerating for 2 meters per second faster every second, do that for 5 seconds, and we will be going 10 meters per second if we started from rest, if we started from initial velocity of 0 and then kept speeding up in the positive direction. So velocity is the area underneath the acceleration. Now the same trend happens again if you want to keep coming down the mountain. Graph velocity, take the area underneath that velocity graph, and you'll get the change in position. And so we see that here on the left. We want to find the area. Well, this is making kind of a right triangle shape, and we see that in orange. And so capital A for area, 1/2 the base times the height. The base is our change in time. The height is your final velocity value here. our 1/2 times the change of time times final velocity will actually give you a displacement. For this case, it would be negative 7.5 meters, and that's a nice little equation that we have in physics. As long as your initial velocity is 0, and your initial velocity was 0, whoop. If your initial velocity is not 0, you have to factor that in, and we have to learn about the kinematics equations to discuss that. Incidentally, if you take the area underneath the curve for a position time graph, there is no area lower than the base of the mountain, so it doesn't mean anything.
That's easy! Stop!
Alright, time for review. If we graph position versus time and you take the slope of that, you will get velocity. If you graph a velocity versus time graph and you take the slope of that, you will get acceleration. If you have an acceleration versus time graph, you can find the area underneath that curve to get your change in velocity caused by that acceleration. And if you have a velocity versus time graph, you can find the area underneath that curve to find your change in position caused by your velocity. Change in position is also called displacement. Thanks for watching. I hope that was helpful. This was the science. I was the science Hutch, and you're the physicist. So you keep on physicsing and have fun with those motion graphs.